So today we're going to talk about quite interesting and important and very widely spread dosage forms: suspensions, emulsions, and also infusions and decoctions. We start from suspensions. And so the suspensions, they are microheterogeneous dispersed systems consisting of solid insoluble medicinal substances in the suspended state, which are in the liquid dispersion medium, water or non-aqueous solvents. Suspensions are divided into dispersed phase. This is our API, our active pharmaceutical ingredient. That, depending on its properties, can be hydrophilic and hydrophobic. And dispersion medium, that is liquid, can be water, water plant extracts, glycerol oils, and so on. Depending on their size of particles, suspensions are divided into rough and thin. Thin suspensions have very little tiny particles, 0.1 to 1 nanometer, while rough suspensions give us 1 nanometer and more. Therefore, thin suspensions, they have slow precipitation. Fast suspensions, they have rough suspensions, they have fast precipitation. Thin suspensions can be obtained only by chemical reaction, while rough suspensions are prepared in the mortar. Suspensions are also divided into those for internal applications, those for external applications, and for injections. Of course, intramuscular, no intravenous. It cannot be intravenous. Because suspension still, it is some kind of a particle, and it may lead to some bad consequences for the organism of the person. They also can be ready to use, like a suspension itself, and powder or granules for preparing suspensions, like antibiotics. When you mix it with water for injection, shake it, and suspension is ready to be introduced into the organism of the person. Rough suspensions are prepared when prescribing substances insoluble in formulated solvent, and when prescribing soluble substances in amounts exceeding the limit of their solubility. What does it mean? For example, last class we have discussed that we have the rate of solubility, quantity of water needed for oil needed for dissolution of this or that substance. For example, for dissolution of the substance, you need, for 1 gram, you need 10 milliliters of water, and you have only 5 prescribed. It means half of the substance will be dissolved in that water, and half of the substance will not be dissolved in the prescribed amount of water. Therefore, it will be a rough suspension. Thin suspensions are prepared only through the chemical reaction. Like you mix two substances soluble in water or in oil, they react and form the third substance that is not soluble in water, and it makes a thin suspension. To increase the suspension stability, it is necessary to increase viscosity of the suspension medium and to decrease the particle size of the dispersed phase by dispersing if it is possible, with doctor's according, of course. To achieve a fine grind of solid power, take half of a part by weight from the substance mass. This is how the Diragin's rule sounds. And it is very important. Anytime you prepare a suspension, you use the Diragin's rule. It doesn't matter whether you prepare it here in Ukraine or in some other country in the world, but still you use the Diragin's rule. So again, for 1 gram of the substance, you take 0.5 grams of liquid. Diragin, this is the last name of a scientist who proved experimentally that when you grind a substance in the presence of liquid, you can get their smaller size of particles rather than just grinding it in dry condition. That is why in suspensions we always use the Diragin's rule all the time, no exceptions. Yeah. For the maximum effect of dispersion in the liquid medium, we use 0.5 milliliter of a liquid per each 1 gram of a dry substance. For hydrophilic, it is water. For hydrophobic, it can be hydrophobic substances or alcohol. Next one. I mentioned that we have hydrophilic and hydrophobic substances. Hydrophilic substances, these are those that are moisturized with water. So when you mix it with water, they basically form, they can be moisturized with water, nothing happens to them, they are mixable. When we talk about hydrophilic substances, like last lecture we have already discussed it, we need to add a stabilizer. So I repeat this material because it is very important for you to remember that you always need to add a stabilizer for hydrophobic substances. You can use these three or any other. There are lots of stabilizers. They are highly molecular compounds that basically just make a kind of a film on the surface of the molecule of the substance and force this molecule to spread inside of the suspension. Dispersion. This is a method of obtaining the certain degree of dispersion by dry medicinal substances and rough suspensions in the mortar. And condensation, this is a chemical reaction method for preparation of thin suspensions. Suspensions with hydrophilic substances are prepared by the following algorithm. Just you remember from the previous lecture, I hope we have already discussed it, so I talk about it briefly. You put a substance in the mortar, grind it in dry condition. Then you add, by the Diragin's rule, 50% amount of the liquid. Grind it this way. Then you mix with water, add water gradually, and your suspension with hydrophilic substances is ready. Suspension with hydrophobic substances get an extra stage. Firstly, grind it in dry condition, then you add stabilizer and mix it thoroughly to cover its surface with its stabilizer. Then you add water, 50% amount from the mass of a dry substance plus stabilizer. And grind it by the Diragin's rule. And after that, mix with water. So you have an extra stage in here. Don't forget about it. And for bismuth basic nitrate, we have a specific technology called making muddy. Bismuth basic nitrate is an extra heavy substance, so you need to add water in several parts. Add water, grind it, wait 1-2 minutes, put the formed suspension to their glass bottle for dispersion. To the precipitation, add another portion of water, and mix it thoroughly, wait 1-2 minutes, put the suspension to the glass bottle for dispensing. To the precipitation, you add water, so you just repeat this action several times until you have a good, stable suspension. If you don't do it this way, then you're going to have a big precipitation formed, unsolved, and of course it's not very good. We are very concerned about stability of suspensions because we may have two problems in here. Sedimentation. It is absolutely normal for suspension, so we just need to shake the bottle and the sedimentation is back to its normal state. And something worse, this is flocculation. Flocculation, this is when the big particles of hydrophobic substance floats on top, and whatever you shake the bottle, nothing helps it. Flocculation means that our suspension is out of its quality, need to be just destroyed, and another suspension must be prepared. Here is an example of the suspension we have discussed it previous time. Zinc oxide and purified water. Zinc oxide is hydrophilic. It's mixable with water. So you put it into the mortar, grind in dry condition, then with a half amount of water, you have 10 grams of zinc oxide. So the needed amount of water is 5 milliliters. So you add 5 milliliters purified water and mix it by the Diragin's rule. Then you add water by parts, forming the suspension, and without straining, without filtering, of course, just pour it straight to the glass bottle for dispensing. Here is the example of condensational method. Zinc chloride, calcium chloride, and sodium hydrocarbonate. When you mix them together, these two solutions, they react with the formation of calcium chloride. Calcium carbonate that basically forms sedimentation that gives us the suspension. Kalium bromide and valeriana tincture. Here is this is an example of condensational method of suspension that is called their change of their solvent. Tincture of valerian includes 70% alcohol because prescribed active pharmaceutical ingredients are not soluble in anything but 70% alcohol. So when you add it to water solution of potassium bromide, part of the substances that actually are not soluble in water, they start forming opalescence. And it is concerned to be also opalescence in muddy mixtures. This is also kind of the suspensions. Now, one more repetition of hydrophobic suspensions. You have terpene hydrate, sodium hydrocarbonate, and water. Sodium hydrocarbonate is absolutely soluble in water. It's good, it's okay to work with it. You just take it in the form of the concentrated solution. And you also have terpene hydrate that is not soluble in anything except of oils, and we have water, no oils. So we should somehow make a suspension out of it. We calculate the stabilizer for it according to the table taken from your dry, soft, and liquid medicinal forms guides. You can take 5% methyl cellulose solution, 2 grams. So you mix that with terpene hydrate and form the suspension. This is how it works. So you put purified water into the measuring cylinder, for example. Add there 40 milliliters of 5% solution of sodium hydrocarbonate and put everything to glass bottle for dispense. And take a mortar, place there 2 grams of terpene hydrate, grind it in dry condition. Then add 2 grams of methyl cellulose, grind it thoroughly, and then add 1 ml of water according to the Dragon's rule, and mix it very carefully. After that, you add by parts water with solution of sodium hydrocarbonate, forming the suspension, and put everything back to the glass bottle for dispensing. Your suspension is ready. Next one, minsol, sodium hydrocarbonate, sodium bromide, purified water. The given medicine is a suspension for external application with hydrophobic substance, volatile substance, minsol, and sodium hydrocarbonate, sodium bromide, 2 substances perfectly soluble in water. We make calculations. Calculate sodium hydrocarbonate and sodium bromide into concentrated solutions. Minus their quantities from the quantity of purified water. Calculate quantity of alcohol from minsol. And calculate stabilizer. Stabilizer is better to be used something like 280, a little bit more effective than 5% solution of methyl cellulose. And this is how you prepare it. So you measure 55 ml of purified water to auxiliary bottle, add solution of sodium hydrocarbonate and solution of sodium bromide. So you have a mixture of them. Then you take a mortar, place a menthol, grind for 5 drops of alcohol because it is a poorly powdered substance you need to crush. It's very, very big crystals. Then you add 2 drops of 280 and titrate until a homogeneous mixture is obtained. Then add, according to the Dragon's rule, half amount of water. So you have 0.5 grams of menthol and 2 drops of 280. So you need to take approximately 0.25 or 0.3 ml of water. It's approximately 15 drops. So you add it from the auxiliary bottle and mix it by the Dragon's rule. Then parts by parts you add water with a mixture of 2 solutions from auxiliary bottle and form them all together, put it into the glass bottle for dispensing. Quality control of suspension is carried out according to state from a copier of Ukraine, usually. Yes. And we move to don't stop on this test because we have already discussed them in the previous lecture. Emulsions. Emulsion is a very specific dosage form. It is a heterogeneous mixture of oil and water. There is only one natural emulsion that you all know. It's milk. Milk, it is oil and water, and some specific proteins that perform as an emulsifier. Pharmaceutical emulsions, this is artificial liquids of white color. They're always white. Also, those of you who interact with some cosmetic creams, cosmetic cream, it's also an emulsion. It's of white color and it is a mixture of oil, water, and emulsifier. So basically, it's a very popular dosage forms in dermatology, in cosmetics in general, and in pharmacy in general. And we need to learn how to prepare them. Emulsions are classified into internal, those ones that their patient drinks, external, ointments, creams, liniments, and parenteral emulsions. For example, emulsion for parenteral feeding. Later, we're going to discuss it, that those patients who are unconscious, they cannot eat and drink themselves, but we need to maintain their health. We are going to give them parenteral nutrition, parenteral feeding. This is exactly an emulsion because you have the mixture of water, proteins, oil, and so on. Yeah, and also blood substitutes. So as you can see, this medicinal form, it's very important to know how to work with it. Today we start working with it and start learning how to make an emulsion for internal use. For internal use, and they are classified into by the type of oil we use. It can be natural plant oil like peach and olive oil. It can be cod liver oil, and it can be some processed oil, semi-synthetic. As an emulsifiers, we use highly molecular compounds and surfactants. There are two types of emulsions, oil in water and water in oil. When we talk about internal emulsions, this is oil in water. The main part is water, and the lesser part is oil. When we talk about creams, and we're going to learn a lot about them next module, next semester after the new year, it will be separately water in oil, oppositely. Complicated multiple emulsions, water, oil, water, oil, water, oil, can be prepared, of course, in their industrial conditions, not in the pharmacy. How can we define the type of suspension? For example, we get a suspension, we have no idea whether it is oil or water. The easiest thing is to dilute it. If you add water and it mixes with emulsion, it is oil in water type. The main body is oil there. If you mix it with water and it is not mixable, then you have the second type. Emulsions are very hot in stabilization. They should have physical, chemical, and microbiological stability. For physical stability of emulsion, it is important the enough quantity of emulsifier, enough dispersion of the phase. And for microbiological stability of emulsions, it is determined by providing a microbial cleanliness to everything. So we cannot filter it, we cannot strain it, but we can sterilize everything before using it, preparing it. Technology of emulsions includes, firstly, the preparation of the corpus or the primary emulsion. This is a mixture of little quantity of water, oil, and an emulsifier. And we can mix it in three ways. After that, we dilute the primary emulsion to the necessary mass. And here are these methods that we can prepare a primary emulsion. As you can see, firstly, emulsifier comes to the mortar. So to the mortar, you always place firstly an emulsifier. If you may prepare it by continental method of Baudrillon. Baudrillon, this is the last name of their scientist who invented it. You place the emulsifier and oil, mix it thoroughly, and then add water. This method is the most commonly used. I can say it's very convenient, and this is what we're going to use mostly. English method. This is when you place emulsifier, then you add water, mix them thoroughly, and then you add oil. The so-called Russian method, this is when you put emulsifier to the mortar, mix it without anything, and then add water and oil and mix all together. This is industrial way of preparation of emulsions, because they prepare this is not in the mortar. In industrial conditions, you take big reactors and mixers, so they can prepare it by the Russian method. How to understand that your primary emulsion is good and okay? You add 1 liter, 1 drop of water. If this water mixes with your emulsion, it's good. You can prepare it. And also you have a kind of a cracking sound when preparing this primary emulsion. If your drop of water stays on surface of emulsion, it means that you still don't have the mixture of the phases and you need to mix it more. How to understand how many and which components to take? According to State Pharmacopoeia of Ukraine, in the other is not indicated by the doctor, you prepare 10% emulsion, 10% of oil. For example, for 100 grams of emulsion, you take 10 grams of oil. For 200 grams of emulsion, you take 20 grams of oil, respectively. For 150 milligrams of oil, you take 15 grams of oil. And as for the other components, here are the composition. Of course, for each kind of emulsifier, you have your own quantity of water for preparing of primary emulsion. There are lots of big tables where you can get these ratios. Here we decided to make your life easier. So we give you emulsifiers that you have already learned as stabilizers for suspension. So these are the same substances. These quantities are given for each 10 grams of oil. So for 10 grams of oil, you use 5 grams of gelatos and 7.5 mils of water, or 2 grams of between 80 and 2-3 mils of water, or 1 gram of methyl cellulose as a 5% solution, it's 20 grams. No water is added because water is already included into 5% solution. How to add substances. It's very hard to stabilize an emulsion, and we should be maximally some issues. We should be maximally careful with the stability of our medicinal substances and the stability of our emulsions when we add these medicinal substances. If substances are soluble in water, you dissolve them in a pot of water intended for dilution of primary emulsion. It is possible to use concentrated solutions even in here and give it to already stabilized and prepared your good emulsion. The same, you add alcohols, syrups, and extracts at the end to the ready-made emulsion. If your substances are soluble in oil, and you prepare oil and water type of emulsion, so nothing's going to it is not going to be dissolved, and you need somehow to do that. So what should you do? You dissolve substances in oil before preparation of the emulsion, and then prepare the emulsion. So substances soluble in water are added after preparation of the emulsion. Substances soluble in oil are added before preparation of the primary emulsion. If you have substances that are not soluble in anything, nor in water, nor in oil, in anything, then you add it as a suspension. By the suspension, you prepare this emulsion and then prepare the suspension with this substance, but you use not water, you use the prepared emulsion instead of this water. For example, the doctor prescribes to you Emulsii olei persicorium 100 grams, caffeine natri benzoate 0.5 grams, use 1 tablespoon 3 times a day. On the reverse side, we make calculations. The doctor didn't specify to us the quantity of ingredients, but he specified which oil he would like to see in the composition of this emulsion. We take 10% out of 100 grams, and we got 10 grams of peach oil. Then we calculate solution of methyl cellulose 5% at 20 grams, according to the table that I showed you. Then caffeine sodium benzoate can be taken in the form of the concentrated solution because we have this table in concentrated solutions. And we just calculate 0.5 on the ratio of our solution, 10, and we get 5 mils. Water for dilution of the primary emulsion, this is the general mass minus quantity of peach oil minus quantity of solution of methyl cellulose and minus solution of caffeine sodium benzoate. Remember that for water, 1 gram equals 1 milliliter, so it's okay for us to recalculate it for grams into milliliters this way. So we get 65 milliliters of water. How to prepare it? In the mortar, you place here it is, sorry, 5% methyl cellulose solution, 20 grams, and mix it without changing the direction of mixing. Never change direction of mixing in emulsions. It is forbidden absolutely. So that like very, very long molecules of your methyl cellulose is spread in one direction. It makes them accurate. Then you add 10 grams of peach oil and mix it without changing the direction of mixing very thoroughly. And while mixing, you will notice that your primary emulsion is formed. So it becomes of white color and looks like a cream and also gives you a cracking sound. But then you take 1 drop of water, place it there and see if your drop of water mixes with primary emulsion, means it's okay. Your emulsion is good, you can't dilute it. If you see it's not, mix thoroughly so that you get a good emulsion. After that, you add 5 milliliters of solution of caffeine sodium benzoate to purified water to the remaining quantity, and by parts add it to the mortar, diluting your primary emulsion, forming the resulting emulsion. When your emulsion is ready, without straining, without filtering, transfer it straight to the glass bottle for dispensing. Next type of emulsion olei ricini and camphor. Camphor is soluble in oils. That is why you will need somehow to add it before preparation of the primary emulsions. Let's have a look how to do that. Firstly, you find out how many castor oil do you need. Olei ricini, in English, it's castor oil. You need 10%. 10% out of 200 grams will be 20 grams. You add 1 gram of camphor to this castor oil and mix it. Camphor is dissolved quite easily. In case if the solution is quite long or crystals are too big, you can put this castor oil with camphor to the porcelain cup and heat it on the water bath up to 40 degrees to make the process of dissolution faster. Then you just calculate how much twin 80 you need, including that oil phase consists of 20 grams of castor oil and 1 gram of camphor. For 4.2 grams of twin 80, you need approximately 5 mils of water for preparation of the primary emulsion, and the rest will be for the dilution of primary emulsion, 170.8 mils. So how do you prepare it? You take a mortar, place there 4.2 grams of twin 80 and mix it without changing direction of mixing. Then you add the mixture of camphor and castor oil and mix them all together. So you have a good mixture of twin 80 and oil phase in your mortar. Then you add literally by drops 5 milliliters of purified water to form a primary emulsion. when you see that it is white, stable, it's cracking, so that's good. You add by drops the rest quantity of purified water by little portions, and your emulsions is good is ready. You place it straight to the glass bottle for dispensing. This is how it looks like, approximately. This is an example of emulsion with peach oil and caffeine sodium benzoate and methyl cellulose. So on the left picture in the mortar, you can see a good emulsion. And on the right, you can see the example when something was prepared wrong. For example, you didn't mix your emulsion in one direction, but you mix it in several directions. As you can see, oil and water, they are like bubbles. Oil looks like bubbles, so it is not spread. It's not mixable. It means that this emulsion is bad and you should start preparation from the very beginning. Of course, caffeine sodium benzoate is a strong effective substance, means that you need to check the doses of this substance. Here is another example, so the same. We have already discussed it. Yes, for quality control, so more examples of emulsions. This is something we are going to calculate a lot during our classes, of course. Today I'm not going to stop on it. You can find this material in Farmel. And we move to quality control and storage of emulsion. It is quality control includes the same written control, questionnaire control, organoleptic control, homogeneity in the absence of mechanical admixtures, physical control, chemical control, selective one, control and despondent. So everything according to the state pharmacopoeia of Ukraine. To make their technology of emulsion preparation better, we have lots of new techniques like new equipment used, some extra high molecular compounds, yet the extension of stabilizers assortment, lots of it. But it's not everything. We also have infusions and decoctions for today. Infusions and decoctions, these are liquid dosage forms represented by water extracts from additional plant raw material and also by water solutions of dry and liquid extract concentrates. Don't confuse them with tinctures. Tinctures are prepared only in industrial conditions, only with the use of ethyl alcohol, different concentrations. Infusions and decoctions are prepared only with the use of water and nothing else, just water. Water is an extractant. It is mixed with dry plant raw material at a certain temperature and during a certain time, and we get water extracts that can be infusions, decoctions, and mucilages, depending on the type of APIs obtained and the time of extraction. We have three different types of extractions. And it is important to understand the ratio. How many water should we add to their plant raw material? It is not a tea. You cannot add water as much as you want, like on an eye. No. Of course, we have certain ratios and calculations. For strong effective plants, like Fulia digitalis and bush pea, Herba thermopsides, I don't know why, in your test, digitalis is called marshmallow. I have not a single clue why do they call it this way, this plant, but digitalis thermopsis, they are strong effective plants, and the ratio for 1 gram of this plant take 400 milliliters of water. Well, they are strong effective, even poisonous. For plant raw material like Herba adonidis, Herba convallaria, Rhizomaticum radicibus valeriana, Semina linii, for 1 gram of this plant raw material, take 30 milliliters of water. For Altea roots, take 20 milliliters of water per 1 gram of roots. All other plants that were not given in the list are prepared in ratio 1 to 10. Per 1 gram of plant raw material, take 10 milliliters of water. The ratio can be different only on the demand of the doctor. Usually they do not give this demand. For example, the doctor prescribes recipe infusi herba hyperici X, 10 grams, 200 mils for rinsing of mouth cavity. So we need to prepare 200 milliliters of infusion out of 10 grams of this herb. We need to make calculations. Here we have very interesting calculations. In all previous calculations, we learned how to decrease the quantity of water because part of the substance take part of the volume, and it is called CVI, coefficient of volume increase. In plants, we have the opposite, absolutely opposite situation. Part of water will be absorbed. And you have here the calculations, how many water do you need to take more, including that the part of this water will be absorbed by herbal material. For 1 gram of their certain plant raw material, there is a certain quantity of water that will be absorbed. 1 gram 10 milliliters of emulsion, 8 gram 200 milliliters of infusion. This is the ratio. This coefficient of volume absorption, of course, is taken from the table. For example, if it is unknown specific one for a certain plant raw material, for root it is 1.5, for flowers and herbs it's 2 grams, for seeds is 3 grams. And here you have Herbophyllonurus, so it should be 2, so you take 2. It means that you multiply the needed quantity of your plant raw material on this ratio, and you plus it, not minus, you plus it to the needed volume of water. So you don't take here just 200 milliliters of water. You take 220 milliliters of water. 20 milliliters will be absorbed by plant raw material. The rest, this is what gives you their infusion and decoction exactly. The time of extraction, it's for infusions 15 minutes on water bath, 45 minutes of cooling down. If it is more than 1 liter, it's plus 10 minutes, 25 milliliters, 25 minutes of extraction. Decoction, this is 30 minutes on water bath, 10 minutes of cooling down. If you have the volume more than 1 liter, then 40 minutes on a water bath, 10 minutes of cooling down. And in case if you have infusion and decoction with indication situ, this is 25 minutes on the water bath and cooling down artificially. Technology of infusion preparation from plant raw materials is very easy. Put the dry plant raw material to the infuser, add water, infuse it on a water bath, cool at the room temperature, strain to the measuring cylinder and press strainer, place it to the vessel, or to introduce the other medicinal substances and put it to the glass bottle for dispensing. The use of concentrated solutions in here is forbidden because all the water that you use it for extraction. Concentrated solutions cannot be used for extraction, so you don't use them at all. And of course, we have specific peculiarities for different types of plant raw material. Technology of water extracts of plant raw material containing alkaloids like bush pea, belladonna, and so on. You extract it by water acidified with hydrochloric acid. As solution in concentration 0.83%, so alkaloids, they are unstable in neutral medium and in alkali medium. So we use hydrochloric acid in the concentration 0.83%, and it helps us to acidify slightly our medium so that our alkaloids are stable. If our plantar material contain cardiac glycosides like digitalis and donis and lily of the valley, pH should be absolutely neutral, nothing is added. And we should be very accurate in temperature and time of infusion. If your plantar material contains ether volatile oils like valerian, milk, chamomile, and so on, extraction is conducted in a tightly closed infusers and strained only after complete cooling of the infuser because they are volatile. So we need to keep in. If you have tannins, oak bark, barberry, rhizomes, then the decoction should be strained without cooling down immediately because tannins are very huge molecules, very big molecules. They form sedimentation immediately. And we need to use it not in the form of the sedimentation somehow. Usually, infusions and decoctions are prescribed without any extra medicines, but sometimes we must add some APIs on the demand of the doctor. If they are soluble in water, they are dissolved in a vessel in the strained water extract. If they are insoluble in water, we introduce them by the type of suspension into the strained water extract and then transfer to the bottle for dispensing. Tinctures, liquid extracts, syrups, everything contains essential oil is added in the last turn straight into the glass bottle for dispensing. A few separate words about mucilages. Mucilages, this is a very specific infusion, viscous solution of highly molecular compound, nitrogen-free matters, similar to the polysaccharide structure. Mucilages preparation is very specific. It always contains something very similar to starch, some highly molecular compounds. And we learn here altea root mainly. Flax seeds, pumpkin seeds, and common plantain seeds also can give us mucilages. And for flax seeds, you need to shake them with hot water 15 minutes. For pumpkin seeds, shake with cold water 5 minutes. For common plantain seeds, shake with hot water 15 minutes. But for altea root, you need to infuse it at the room temperature for 30 minutes without shaking, without mixing, without anything. Like mix, put altea root to the infuser, add some room temperature water without heating, without anything, and leave it. Don't touch it for 30 minutes. And you will get the process of maceration there. And the ratio for altea root is 1 to 20. A few more words about extra concentrates. Of course, working with plantar material is hard, is long, it requires lots of time because it's straining, filtering, infusing, it demands time. And of course, we try to make our life easier and to improve the quality of our medicines for patients. That is why extra concentrates were created. Extra concentrates, these are specific groups of standardized extracts intended for the preparation of infusions, decoctions, and all other dosage forms. These are medicinal forms of liquid, soft to solid, consistent, obtained from medicinal plant material or animal material in industrial condition. We take it as a substance. We don't prepare it in the pharmacy. We take it as a substance prepared by high quality standard, very convenient to use, absolutely standardized. They can be dry and liquid. They are always easily soluble in water because they are prepared with the help of water. And dry extracts are taken in the same amount as the given amount of plant material in the prescription. They are already made so that they correspond to the prescribed quantity by the doctor. Liquid extracts are usually prepared, are taken in double amount because they halfly contain a part of water. And of course, when we work with these extracts, yes, they are like a substance, we use CI, we can use extra concentrates, so we work with them as if we prepare an ordinary mixture, not an infusion or a decoction. It's very easy to work with it. You measure to the vessel, auxiliary bottle, your purified water, dissolve dry extract, dissolve all other dry substance if they are prescribed, add some concentrated solution if they are prescribed. Strain everything to the glass bottle for dispensing. In the last turn, add tinctures, liquid extracts, standard solutions, some essential oils. So their technology is very, very easy. So basically, this was everything that I wanted to tell you for today. Thank you for your attention. You can be free and don't forget to be on time to come on Wednesday on our class. Thank you so much and have a nice day.